Hello everyone, welcome to ICSE Physics, keeping intellectually engaged. Today in this session, we are going to deal with chapter 1, force of your ICSE Physics course book. I hope in grade 9 all of you must have studied about force, right? When force is applied on a rigid body, it can produce motion in it, while when applied on a non-rigid body, you know that it can bring about both a change in its size or shape or motion. Force is defined as the rate of change of momentum. F is equal to mass times acceleration. Force is a vector quantity and its SI unit is Newton or kilogram force, and force can be measured with a spring balance. These are the basic concepts or ideas that you have studied in grade 9 or gained in grade 9. Now we start with an important topic, that is moment of a force and equilibrium. We will proceed exactly according to the syllabus prescribed by ICSE board. Before we learn about moment of a force and equilibrium, we must understand what is translational and rotational motion. We know that when a rigid body is being acted upon by a force, it can have two kinds of motion, translational motion or rotational motion. Translational motion is also known as linear motion. Linear motion. You have studied about linear motion and examples of linear motion in lower classes. For example, what is translational motion or linear motion? Consider a ball resting on the ground which is stationary and it is not fixed, you know that it is free to move. When a force acts on a ball, suppose you are pushing the ball, you are applying a force and ball starts rolling in the direction of the force applied. This is the force of push. This type of motion we call it as linear motion or translational motion. So, in linear motion, the rigid body is not fixed, it is free to move. When we apply force on this type of rigid bodies, it moves from one place to another place, that we call it as translational or linear motion. Example, a ball rolling on a ground. You can see other examples around you. Motion of a car along the road is an example of linear motion. Now, what is rotational motion? Let us consider a case of a wheel. You know what is a wheel? A wheel is a circular body which is fixed at its center. This fixed point we call it as point of pivot. It is pivot at the point P here. What happens when you apply force on this body? Suppose I am applying the force on this body tangentially like this. What will happen to this wheel? You know that wheel will rotate about the fixed point. When the force is applied tangentially on its rim of this wheel, the wheel starts rotating about the fixed point. This is the turning effect of force. The force brings about an effect called turning effect, and the motion of this body is called rotational motion. So, the body rotates in clockwise direction, Okay. Let us cite another example of rotational motion. For example, you are playing a seesaw in the garden. I am quite sure that all of you must have enjoyed playing seesaw in your childhood. What is a seesaw? Seesaw is nothing but it is a simple bar fixed or supported at the fulcrum. It is fixed at the fulcrum. When you are sitting on one edge of the seesaw, what happens? The seesaw rotates. The seesaw rotates about the fixed point in the anticlockwise direction. This is the turning effect of the force, and the motion of a body we call it as rotational motion. Examples: What are the examples of rotational motion? Other examples of rotational motion you find in your day-to-day life. Opening a door is an example of rotational motion. You know that the door is fixed to a fixed frame, and when you open the door moves about its hinges. So the motion of the wheel, motion of seesaw, opening of a door are the examples of rotational motion. So body rotates when a body undergoes rotational motion when it is fixed and you apply force on it. Remember that when the body is fixed at a point and if you apply force on the body such that the body is not free to move, it will not execute any linear motion or translational motion, it will execute rotational motion. Clear? So when a force is applied on a fixed body which is not capable of moving, the body rotates about the fixed point in clockwise direction or in anticlockwise direction. Then what is clockwise and anticlockwise direction? You may know it. For that we will consider an analog clock hanging on your wall. Its needle always move from 12, 1, 2, 3. So the motion of the needle or the handle of the clock from 1, 2, 3, this direction, from 12 to 3, we call it as clockwise direction. Clockwise direction. Conversely, the motion of the handle of the clock from 6 to 3, 3 to 12, we call it as this direction. We call it as anti-clockwise direction. So remember that when a body is fixed about a point and the force is being applied on the body is capable of rotating about the fixed point in clockwise direction and anti-clockwise direction. Right? Now let us get introduced with an important topic, that is moment of a force or torque. Moment of a force is also known as torque. To study about moment of a force, let us consider a very simple example of seesaw. All of you are familiar with the seesaw. What is a seesaw? A simple rigid bar fixed at a point, fixed point, call it as fulcrum. Suppose you are sitting on one end of the seesaw at B and you are exerting a certain amount of force. What happens? What do you notice there? Your force is unable to produce any linear motion. Since this body is fixed there, it can rotate about the point F, about the point fulcrum. So it turns in clockwise direction. When you are sitting at the end B, the seesaw turns in clockwise direction. At the same time, another boy is sitting at the end A. Because of his weight, he is applying a force, and this force is capable of producing a turning effect, or it can rotate in anti-clockwise direction. Thus, the body rotates about the fixed point. The seesaw rotates about the fixed point due to a certain factor or a certain quantity. What is that quantity? So we can say that the turning effect on the body about an axis or about the fixed point is due to a factor called moment of force or torque. So the torque is responsible for producing turning effect on a body which is fixed at the point fulcrum. So how can you define torque? Torque is nothing but the turning effect on the body about an axis is due to the moment of force or torque. Concept is clear to you? Alright. Now we got to know about moment of force. It's also known as torque. Now, what are the factors affecting the turning of a body? How can we measure the moment of force or torque? Let us again take the case of a seesaw. While playing a seesaw, you might have noticed that a heavy boy or a heavy person can produce more turning effect as compared to a lighter one, a lighter person or lighter boy. All right. So we can say that moment of a force or torque is directly proportional to the force applied on one end of the seesaw or anywhere on the body, right? Yes. Now what is the another factor controlling the moment of force? In order to understand that, let us take the example of opening a door. Every day we open and close the door many a times. So this is the door. Look at the diagram drawn on the board. This is the axis of rotation. We call it as fixed point or axis or fulcrum. Okay. And we apply, in order to open the door, we apply force at a point far away from the fulcrum. So when you apply force at a point far away from the fulcrum, we can easily open the door. Very smooth. At the same time, you try to apply force at a distance very closer to the, now you apply force or you change the point of application of the force closer to the fulcrum. What do you experience? In first case, you applied force on the edge where the handle is fixed. Now in the second case, you have changed the point of application of the force to a point which is closer to fulcrum. What do you experience? Obviously, you will experience certain level of difficulty in opening the door, right? From here, we can understand the distance between the point of application of the force and the axis of rotation, that we call it as perpendicular distance. The perpendicular distance D. What is perpendicular distance? The perpendicular distance is the distance between the point of application of force and, this is the force, and the fulcrum, the fixed point. So when the perpendicular distance was more, you could easily open the door. When the perpendicular distance was less, you felt some difficulty. So obviously we can say that the torque is controlled by another factor, that is the perpendicular distance between the point of application of the force and the fulcrum. All right? Yes. So we can express the torque T is equal to product of force and perpendicular distance. Very important formula. Learn it. Torque is equal to force, the product of force and the perpendicular distance of force from the point of rotation. All right? Yes. So the question can be asked, mention the factors affecting the turning of a body. You can write the turning effect of a body or the moment of a force or the torque depends upon the force and the perpendicular distance between point of application of the force and the fulcrum. So note that for a given force, more the distance between force and the point of rotation, more easily we can open the door. The more will be the torque, because torque is directly proportional to force and distance. For a given force, by increasing the perpendicular distance, we can increase torque. Clear to you? Okay. Now we can express or we can measure moment of a force or torque as the product of force and perpendicular distance between the point of application of the force and point of axis of rotation. Torque is equal to force into perpendicular distance. So remember formula, note down all the formulas of the lesson, and at the end of the lesson make a formula chart for your convenience. All right. So what is the physical meaning of this formula? Torque is equal to force into displacement. It means that torque is directly proportional to force. The more the force, more will be the torque. And again, torque is directly proportional to the distance between the point of application of the force and the axis of rotation. More this perpendicular distance, more will be the torque. All right? Yes. Now what are the unit of moments of force? What is the unit? We got an important physical quantity, moment of force or torque. Of course we have to assign a unit. So we can derive the unit when you know the formula. Force is expressed in Newton and distance is expressed in meter. It's a compound unit. So the torque T is expressed as Newton meter. So what is the SI unit of torque? It is Newton meter, Newton into meter. This is SI unit of torque or moment of force. What is the CGS unit of this? Yes, CGS unit. The CGS unit can be written as, again, the force torque is equal to, force is expressed in dyne and the distance is expressed in centimeter. So torque is equal to, in CGS unit it is dyne centimeter. Okay. So 1 Newton meter is equal to, 1 Newton is equal to 10 to the power 5 dyne, we know it, and 1 centimeter is equal to 10 to the power, 1 meter is equal to 10 to the power 2 centimeter, right? Therefore we can write 1 Newton meter is equal to 10 to the power 7 dyne centimeter. So remember that 1 Newton meter is equal to 10 to the power 7 dyne centimeter. All right. I hope the points are clear to you. Now, what are clockwise and anti-clockwise moments? What is its nature? I mean, whether it is positive or negative. We have studied that when a force is applied on a body which is fixed at a point, it is capable of rotating about the fixed point. And the turning effect is always produced by the moment of a force or torque rotates a body. If the effect on the body is to turn it in anti-clockwise direction, the effect of force is to turn in anti-clockwise direction, that moment we call it as anti-clockwise moment. What is its nature? Whether it is positive or negative. Anti-clockwise moments are taken as positive. Anti-clockwise moments are taken as positive. How do you remember? Anti-clockwise moments are taken as positive. Very simple. Take the case of a screw. In order to unscrew a screw using a screwdriver, you give anti-clockwise rotation, right? So the screw moves up. When you are giving anti-clockwise rotation on a screw with a screwdriver, the screw comes up. And you have learned in Cartesian sign convention that any measurement which is made upward is taken as positive. So when you are unscrewing a screw, the screw comes up, the moment is anti-clockwise in nature and the sign is positive. Okay. So what about clockwise moment? If the effect of the force or effect on the body is to turn in clockwise direction, that we call it as anti-clockwise moment. If the effect of the body is to, effect of the force on a body is to rotate in clockwise direction, we call it as clockwise moment. What is its sign or what is its symbol? It's negative. Clockwise moments are always taken as negative. So anti-clockwise are positive, clockwise moments are negative. Again, take the case of a screw. We have to fix the screw into a frame. We give clockwise rotations, right? With the help of a screwdriver, we give clockwise rotation. When we give clockwise rotation, the screw goes down. The movement of the screw in the downward direction. And as per the Cartesian sign convention, any distances which are measured below x-axis is taken as negative. So the clockwise moment is taken as negative, anti-clockwise moment is taken as positive. Remember this point. Okay. Now the question is, how can you change the direction of rotation of a body? It's a board question. Suggests two ways of changing direction of rotation of a body. The first one, by changing the point of application of the force. Look at this diagram drawn here. Here the force is acting at this point and it produces an anti-clockwise moment which is taken as positive. Now I have changed the point of application of the force here. In the second case, it produces a clockwise moment which is taken as negative. So, by changing the point of application of force, by changing the point of application, the point at which the force acting here, I have changed in both cases, please notice it. So, by changing the point of application of the force, we can change the direction of rotation of a body. In the second case, the second method, by changing the direction of the force. Now, change the direction of the force applied. Look at this diagram. I have applied the force like this. So, the body, the tendency of the body is to rotate in anticlockwise direction, producing an anticlockwise moment, which is taken as positive. Now, come to the second case. So, here I have changed the direction of the force applied. I am applying the force in this direction. The tendency of the force is to rotate the body in the clockwise direction, producing clockwise moment, which is taken as negative. So, anticlockwise moments are positive, clockwise moments are always taken as negative. So, these are the two ways by which we can change the direction of rotation of a body. What all are they? By changing the point of application of the force, by changing the direction of force. Now, can you suggest some common examples of moment of force in our day-to-day life? Very simple. Opening and closing a door. First one, opening and closing a door. Another one, turning a steering wheel. All of you are expert drivers, right? You may be driving a car or by controlling on a steering, right? So, turning a steering wheel is an example of common examples of moment of force. Another example, turning off a twisted wheel of a bicycle. When you are riding a bicycle, you apply force on the foot pedal and there is and you produce motion on the cycle. There also a moment of force is employed there. So, turning off a twisted wheel of a bicycle is an example of moment of force. So, the moment of force T or torque T is equal to force into perpendicular distance, very important formula. Torque, you can increase the torque by increasing the force or by increasing the perpendicular distance between the axis of rotation and the point of application of the force, you can increase torque. So, torque is equal to force into displacement. I hope the points which I have discussed are clear to you.